Greetings to you, ladies and gentlemen. Welcome back to Engineer Shek's YouTube channel. Today we're going to talk about sensor calibration and input devices. All right, and this could be under physical computing and IoT, or we also do this in fundamentals of digital electronics. So if you are doing any one of the two modules or courses, this is useful for you. So without wasting time, I will just encourage you to like if you like it. Don't like it if don't click on the like button if you don't like it. Comments, you can give me your suggestions and your contributions and anything that you feel can motivate me, can improve the channel, can improve the content that I'm uploading. Share with your colleagues, those who you think needs to understand or need to get this information or this message that we are sharing here. And most importantly, don't forget to subscribe so that you don't miss out on any new video that I upload on this channel. So now I will give you a recap of what we've talked about. Uh, These are the main hardware components of the computer, of any computing device, be it a controller board, be it a microprocessor, maybe microprocessor no, because this one is a bit bigger as compared to a microprocessor. So we accept analog to digital converter does the thing, sends the signal to the processor takes the signal to the output, and then we get that. Because the signal is already converted to digital, then we can send it to output as digital. Now we want to read values from the real world. I think that we emphasized this in the previous talks. Reading values from the real world. Right. So what we are doing here is, you can observe that here we have the input, we have moved it to our far right. So the input is taken and then the signal is taken into the device or the computing device. But what is it that we are taking into the computing device? It is something that is coming from the real world. And the real world consists of environments. And we've talked about the environments, including water or liquid, air or gas, or some can call it wind. We can also talk about the land. So what can we read from the real world? We can read moisture using the moisture sensor. We can read temperature using temperature sensor. We can read pressure. We can apply human controls as digital in this way. Carbon monoxide can be measured using MQ7 sensor. pH using pH sensor. But what happens with all these? All these values, all the values we get from the environment through the use of these sensors, they go to the input pins of our controller board. So this is exactly what happens. But now we've got many other millions of sensors that we may make use of. So these are the millions of sensors that we make use of. They also send signals to the controller board through the input ports. So you have to understand the input ports whenever you talk of a controller board. Understand the inputs. Is it analog? Is it digital? If it's analog, then what? If it's digital, then what? So all these are just samples of the sensors that we may make use of. But these sensors, they need to read the actual real world represented values. But for this to happen, there is a process that you need to go through, which is what we call calibration. Calibration. So let me just talk about analog to digital conversion before we talk about calibration. So what happens is we assume that the value that is coming from the sensor is just like that. We've talked about this. And then we send analog. So we get input from the real world, that is from the sensor. The sensor gives through the input pins. So meaning to say the input pin is connected to the sensor. And then the value gets through, we get the value through the sensor, the ADC, the processor to the DAC, DAC to the output. Or the other way around, analog input to ADC, ADC to processor, processor to digital output. Yeah. So this is just a recap about analog to digital conversion and digital to analog conversion. Now, before we actually get the values like you can see here, we have to deal with the values that we are getting and then work with them in such a way that they are the actual representation of the real world signals. So to do that, we have to do a process called calibration, sensor calibration. So this process is just a task or a set of tasks that serve to determine under defined conditions the relationship between the values of a measuring output by a measurement instrument, such as a sensor or measuring system with corresponding measurement uncertainty and corresponding values of a measurement established with standards that correspond to measurement uncertainty. Let me just give you an example of sensor calibration. Let's just say I've bought a new temperature sensor, say LM35. So if I want to calibrate the LM35, what I may do is I know the temperature of water that reached the boiling point, and I know the freezing point, the temperature of the temperature value that we read in degrees Celsius of the freezing point. So I can just take the sensor that I've bought, read the value on something that is frozen, that we are certain that it has reached the freezing point. And then we read the temperature of water or anything that we are sure it has reached the boiling point. Then we can actually come up with a formula that determines the temperature values based on the range that we could have gotten from our readings. Then that formula is now used to get the actual values. Now, the values that we will be getting, we may actually say we need to make use of an existing temperature sensor that we are sure it's giving us true values or true representation of the real world temperature values. Now we compare the two and then we do some adjustments. Those adjustments are different from calibration. Now, why is sensor calibration so important? It is important because you can actually verify the precision and reproducibility of measurement instruments, such as sensors and measuring systems. Sensors are Sensors that are calibrated are the prerequisite for preciseness, reliability, reproducibility of the measurement results. So the calibration is the one is one of the key prerequisites of effective quality assurance. The values that we're going to get are the true representation of the rule. So calibration, as I said, is the prerequisite or for effective quality assurance. How is calibration documented? The result of calibration is documented by means of a calibration certificate or calibration report. So let's assume that you are doing a research or a project. You do your sensor calibration, and then the results of your calibration needs to be known in a certificate or through a report. So you have to compile a report which tells us to say if you are reading this value with this sensor, it means this value in the actual world representation. So by specifying the standards, these documents can verify traceability to national and international standards. So the result of calibration is expressed by means of a specification, a calibration function, a calibration curve, a calibration table, or a calibration diagram. So the function is the one that we are talking of as a formula. You can actually draw a table generating the values from the function. You can have a diagram or a curve coming up from the function. So that's how that's how calibration is documented. And then what details must a calibration certificate include? It includes designation of the test specimen, unit under test. Are we testing centimeters, meters, parts per million, and stuff? Documentation of the competence of the person responsible. Are we talking with a doctor? Are we talking with somebody holding a master's degree? Are we talking with an undergrad? Are we talking to somebody who is just from the street? Documentation of the reference standard and of the traceability. Documentation of the ambient conditions, measurement result, including the measurement uncertainty. Maybe we are talking about the variance. Description and documentation of the applied procedure. The date calibrations must be repeated at regular intervals. Because what happens is, let's assume that you are measuring carbon monoxide emissions from vehicle exhaust tailpipes. What happens is the sensor gets, what can I say? The sensor loses the preciseness, loses performance as time goes on. So you need to calibrate it time and time as you go up until your sensor is no longer capable of performing some measurements. And then what is recalibration and why is it essential? I think I've said it in some ways. The accuracy of even the most precise and most sensitive measurement instrument or measuring system can deteriorate through wear, aging, and environmental influences. It should therefore be recalibrated at regular intervals. That's why we need to specify the intervals for recalibration. So DIN and ISO 9001 specifies that a process for test equipment monitoring should be introduced and that the measuring equipment must be calibrated. For this reason, many companies have quality assurance systems that stipulate calibration at regular intervals. So how are sensors for different measurements calibrated? Sensors are calibrated in different ways depending on the measured. Different calibration processes and calibration machines are used for pressure sensor calibration, force sensor calibration, torque sensor calibration, and maybe accelerometer calibration. So what does traceable calibration in an accredited laboratory mean? Such a calibration is performed in an accredited laboratory in accordance with DIN and ISO IEC 17025 and always includes specification of the measurement uncertainty. This standard implements the specification of the international vocabulary of basic and general terms in metrology and ensures the quality of the calibration laboratories traceable. All these details I'm giving you, they are based on DIN and ISO IEC 17025. So only such calibration guarantees the full metrological traceability of national standards. So that's it for today. Thank you very much, ladies and gentlemen, for attending, for paying attention, for giving me the likes, the comments, sharing with colleagues, and most importantly, subscribing. May God bless you in everything that you do. Enjoy the rest of your day. Goodbye.